In this pre-calculus algebra video, we're going to be writing a circle in standard form by completing the square. Now, what we're going to do in this video also applies to all the conic sections. And when we say conic sections, that means we're thinking of the curves. The circle, that's a conic section. The ellipse, parabolas and hyperbolas. So the technique we're going to do for writing the circle in the standard form in this video also applies to these other conic sections that we're going to be studying later on in this course. All right, let's see how this goes. So let's show that the equation represents a circle and then find the center and the radius of that circle. So right now what we see is that we have an equation with quadratic terms and linear terms and a constant. So recall that the equation of a circle generally is this. It's x take away h squared plus y minus k squared is equal to r squared. Now when you write a circle in this way, the center is the ordered pair hk, and the radius, so that would be the center, and the radius would be r of the circle. So what we want to do is we want to write the left-hand side of the equation in basically this form, and taking the constant over to the other side. Now when I look at this general form here, I can see that I've got x take away something squared, right? A whole quantity squared, but I don't see any linear terms in x floating around. Like in other words, I see a quadratic term here containing x, but I also see this linear term, that is x raised to the first power, off to the side. We want one single expression that has been squared that sort of encapsulates both of those terms. And the same thing with the y, right? Everything, we have this whole quantity squared, and so there are no linear factors of y floating off. And then of course there's no constant on the left hand side, so we want the constant on the right hand side. So the first thing we're going to do is we're going to put all the terms with x together, the x squared and the negative 4x, and the same with the y, and we'll take the 13 over to the other side. So we're going to write this as x squared minus 4x plus y squared plus 10y is equal to negative 13. Okay, that's just a rearranging of terms, and we're prepping this problem for completing the square. Okay, so the idea is that we're going to complete the square on these terms. That is, you can see this is a square, right? So I want to turn basically this into something that looks like that. And when we do that, we call that completing the square. And likewise with these two terms, the ones involving y. So the way you complete, so just focusing on these two terms right here, the way you complete the square is by taking, what you first of all have to make sure that the lead coefficient is a 1 in front of x squared. So it is a 1, right, because we don't see anything written there. And then what you do is you take the middle term, the one involving x, and you take the coefficient, which is negative 4. You take half of that coefficient, which is negative 2, and then square that. So when I square negative 2, I get positive 4, and then I add that in. So I'm going to write this, x squared minus 4x, and then plus 4. And we'll see what effect that has in a minute. Let's do the same thing with these terms. Check to make sure the coefficient is a 1. It is, on the y squared. Take half of the coefficient attached to the y. So half of 10 is 5. Square that 5, and that gives you 25. So we're going to add that in as well, and we get plus y squared plus 10y plus 25. Now you might say, well, wait a minute, how can you just add in 4 and add in 5? And you can only do that if you add, whatever you add to the left-hand side, you also add to the right-hand side. So the right-hand side is not going to just be negative 13 anymore. It's going to be a positive plus 4 and then a plus 25 as well to balance out what I did on the left-hand side. Now I've completed the square. That is, these three terms taken together, that is including the 4 I just put in there, that can be written as x take away 2 whole thing squared. And you can check it, right? If you expand that out, you're going to get those three terms. And likewise, plus, right here, for these three terms, I can write that as y plus 5 squared. And that's what adding the 4 and adding the 25 did. They allowed us to complete the square. These are now perfect squares. And the right-hand side is what? Well, adding these all together, it's 29 minus 13, or 16. And now I can see that I've written that equation, the original equation, in this equation, and I can see when I compare it with this equation that this is the equation of a circle. And what would h be? H would be 2, k would be -5, comparing it with this, and then r, the center, would be 4, right? Because it's r squared on the right-hand side, and 16 is 4 squared. So my center is going to be the ordered pair 2, -5, and the radius is +4. Okay, so this would be my answer. I showed that it was really an equation of a circle, and the center was 2 and -5, the radius was 4. And like I was saying, we're going to use this technique for other conic sections, including the ellipse, the parabola, and the hyperbola. So completing the square is a pretty powerful tool for us. All right, until next time.